You're copying me!
Oh, is it a video?
It all started in 1945, after the horror and trauma that was caused during World War II, when the American B-29 bomber dropped the world's first atomic bomb over Hiroshima. Nuclear energy was a technological spin-off that was promised to provide massive amounts of energy. However, it was a shaky start. Harnessing nuclear power is easy to do on paper, but monstrously difficult to do in real life, as during its inception, many private companies were reluctant to invest in nuclear power, and would rather invest in already successful power sources like coal, oil, and gas. However, nuclear reactors did have major hype surrounding it during the beginning of the 1970s, and many reactors were built between the 70s and the 80s. But what type of reactors should we build? Given how many different types of reactors there were at the time, a big favorite was the light water reactor. Although common, was widely used because it's there, it works, and it's cheap. What does a light water reactor do? Simply put, according to an article by Bobby Zervain titled Into the Light Water Reactors, published in the Academic Journal of the US NRC, a light water reactor heats up the surrounding water in its core, using artificial chain reactions, which uses the steam it produces to power the turbine. Nuclear fission releases several million times more energy than any chemical reaction could. Heavy elements on the verge of collapse, like uranium-235, get bombarded by neutrons. The neutron gets absorbed, and as a result becomes unstable. Most of the time, it immediately slips up into fast-moving particles. Some become additional free-moving electrons, and some become energy in the form of radiation, which heats up the water. And finally, the neutrons repeating the process, generating more and more energy. Now, with all the history and science out of the way, there's huge controversy that surrounds whether or not we should continue using nuclear energy. But in my dispute, nuclear energy is a source of untapped potential, as it could help dampen the global warming crisis, help save countless of lives, and help innovate more effective technologies to save nuclear waste and dangerous meltdowns. One side of the argument is that nuclear energy is far more efficient and cleaner than any energy source we may have, while the other side of the argument explains that further research in nuclear energy would cause a surplus of nuclear weapons to be created. Nuclear energy, on average, reduces tons of CO2 emissions and greenhouse gases, which is widely known as the main catalyst to global warming. According to a study conducted by the International Atomic Energy Agency, titled Nuclear Power and Climate Change, nuclear power, on average, is one of the lowest emitters of greenhouse gases that are available, due to only producing steam from its reactors. As a result, the use of nuclear power helped avoid emissions of up to 2 billion tons of CO2 every year, which is the equivalent of 400 million cars off the road per year. While also noting that the world is only growing in population every year, and energy consumption is only rising up compared to all the other things that we do that harm the climate we live in. If nuclear power is a good idea to stop long term, it might just be the solution to use for the next 100 years. One argument against nuclear power is the cause for concern that nuclear reactors have a long history of accidents and disasters. Taking a brief look into the history of nuclear accidents worldwide, there's a short report by the US SUSA titled A Brief History of Nuclear Accidents Worldwide. Over the 6 years that we have used nuclear reactors, there have been 7 major accidents globally. 3 of the accidents were mostly contained, but out of 4 of them were released significant amounts of major radioactivity into the environment. In 1957, 1987, and 2011, large parts of Ukraine, Russia, and Japan for decades to come were uninhabitable, while the number of deaths, although not exact, were estimated to be in the thousands. However, if we take a different approach and look at the whole spectrum and pin up the number of deaths caused by nuclear reactors, for example, like fossil fuels, according to a study conducted by NASA, published by Pusher Kercha, titled Vital Signs of the Planet, if we take a look into the amount of deaths per energy unit generated per year, and also take into account all the deaths that occur in every nuclear reactor disaster, nuclear power is last in generated deaths, even behind wind and hydro generators. Although nuclear waste is really toxic, it's usually well contained and stored somewhere deep underground, versus the toxic byproducts of fossil fuels generated every day being pumped into our atmosphere. And as a result, just by preventing large amounts of fossil fuel buildup in our atmosphere, countless cases of cancers and lung diseases have been avoided and helped save over 1.8 million lives between 1971 and 2009. Another argument is the worry that nuclear waste buildup. Spent nuclear fuel is not only radioactive, but also contains large amounts of poison chemicals like plutonium, which takes up to tens of thousands of years to become harmless. There's also a process called reprocessing, which extracts the plutonium from already spent fuel and reuses it on more fuels for reactors. But there's a problem with that. Hardly, if any, is actually used for fuel because we don't have the right reactors for that. Where would all the waste go? After dumping it in the ocean was ruled out, scientists tried finding a place to bury it in different locations where it definitely won't be disturbed for tens of thousands of years. Nonetheless, with time comes innovation and the chance for new technologies to be. Innovation will help solve all those problems that I've mentioned, from unspent nuclear fuel to preventing accidents. If you remember, most nuclear reactors were made between the 70s and the 80s, thus meaning that most reactors today are old and outdated tech. One promised reactor in development are thorium reactors. In an article published by the World Nuclear Association, we would come to know that thorium is abundant, it's hard to turn into nuclear weapons, and is 2 times less wasteful than conventional reactors. While also noting that the waste material produced by thorium would only be radioactive for 100 years instead of the thousands of years. It is also estimated that only 1 ton of thorium can have the same energy output as 200 tons of uranium, or 3.5 million tons of coal. With everything that I've said so far, we can't be completely sure that nuclear energy is the magical bullet to solve the world's power consumption. The pros of nuclear energy are definitely out there, but instead of foregoing the opportunity to solve those said problems, we should definitely try our hand in improving outdated technologies and make informed decisions rather than gut feelings, and hopefully just a little bit improve life on Earth. Thank you.
Thank you.